Greetings everyone, and happy almost St. Patrick's Day. May the luck of the Irish be with you as you tackle this month's problem. There's sure to be a pot of gold at the end of the rainbow for all who work through it. Without further ado, let's get started.
Today's Math Fix is brought to you by G-MG.A.3, which asks students to apply geometric methods to solve design problems. Let's take a look at our problem today. Students are asked to help Jing decide if the robot her sister Lulu created to retrieve tennis balls for her is worth using. Lulu has tested it out in their driveway, but is it efficient enough to use on the tennis court? Let's find out. Students will probably want to start by calculating the average speed of the robot using what they know about its performance in the driveway. To do this, they will have to estimate some distances. Assuming an average two-car garage, they can assume dimensions of, say, 24 by 40 feet for the driveway. So, if we think about the driveway as being on a coordinate plane then, the shortest distance from 0, 0 to another edge of the driveway would be 24 feet, and the longest distance would be the distance to the coordinate 40, 24. To calculate the longest distance then, students can use the Pythagorean theorem and find that the longest distance would be about 47 feet. So, the average distance then can be found by averaging 24 and 47 to get 35.5 feet. So, given what Lulu found out in the driveway, we could say that the robot can travel at an average speed of about 5 feet per second. Now, thinking about the tennis court, a regulation tennis court is 78 by 36 feet for doubles matches. We know that the robot travels at an average speed of about 5 feet per second, but now we must think about where the robot might be traveling. Most likely, the robot would need to start from a random point on the court and then travel to another point to retrieve the ball. So again, thinking about the tennis court like a coordinate plane, students might start by randomly choosing a spot on the court for the robot to start, say 8:10, and end at, say 56:28. Using the distance formula then, students can find out that the distance between these 2 points is about 51 feet, which means this will take the robot approximately 10 seconds to travel this distance. Students can then use reason to think about if this might be an average distance, if they think more often than not the robot will travel shorter distance, and if Jing can retrieve the balls quicker. One extension might be to ask students to think about other applications of robot technology that they can think of that might be useful.
And that's this month's Math Fix task, folks. There's only one more Math Fix test for this year in April, so we can't wait to share it with you. Until next time.